Hello and welcome back to Math Class in Session. Let's start a unit on sketching functions. We'll start with increasing and decreasing functions. So we're going to look for intervals of increase and decrease. We say a function is increasing on an interval AB if for all x1 less than x2 in the interval AB, f of x1 is less than f of x2. Or in the vernacular, the bigger the x, the bigger the f of x. Notice x1 grows to become x2. x1 is less than x2. And f of x1 grows to become f of x2. The bigger the x, the bigger the f of x. And the flip side of the coin, we say a function is decreasing on an interval AB if for all x1 less than x2 in the interval AB, f of x1 is greater than f of x2. Or in the vernacular, the bigger the x, the smaller the f of x. More simply, if a function is increasing, it slopes up with a positive derivative. And if a function is decreasing, then it slopes down and its derivative will be negative. Therefore, to find intervals where a function is increasing or decreasing, one analyzes the derivative on the intervals of the real number line between the critical numbers. Example, state the intervals of increase and decrease for a cubic function. Solution. Our approach will be to find the critical numbers and draw a number line. How do you find critical numbers? Well, you prime it, zero it, and solve it. Prime it, set it equal to 0, and I divide it through by 3. And now solve it. Well, it's a quadratic we can solve by factoring. And so we have critical numbers at x equals 6 and x equals negative 2. Now we're going to draw this number line. And I've labeled this a f prime of x number line. And on that number line, we'll put the critical numbers and any numbers that the derivative is not defined at. But there are no such numbers in this case. So we'll put the numbers minus 2 and 6 on this number line. Make sure you put the minus 2 to the left of 6. Now we've divided this number line up into 3 sections. Notice how there's always one more section than there is entries. 2 entries, 1, 2, 3 sections. And our task is to determine if f prime of x is positive or negative within each of these sections or intervals. We know it can't be 0 because if it was 0, that would be an entry because these entries are the critical numbers. So this entire section, for example, is either all positive or all negative because it can't touch 0. Because there's an arrowhead here, we can sub in something large and negative to the derivative, because this is a derivative line, something large and negative. If it's large, we can ignore these terms because something squared becomes huge. And so we can just think to ourselves, something large and negative when squared goes positive. And so this entire section is positive. To evaluate this section, we need to pick a number in it, like, say, a number between minus 2 and 6. A convenient number is 0. Take 0 and plug it into the prime. Don't be tempted to sub it into the original. It's a prime line. Sub it into the derivative, and we'll find out that it turns out to be negative 36, because these two terms disappear if we're subbing in 0. Negative 36 is negative, so this entire section is negative. And lastly, this interval on the right has an arrow on it, so we can sub in something large and positive into the derivative. And of course, these two terms become insignificant, and something large squared is still positive. And so we get that entire section is positive. Now we can state the intervals. F of x increases wherever we see a plus sign. So x less than minus 2 or x that's greater than 6. And x decreases wherever we see a negative sign. So minus 2 is less than x, which is less than 6. Between minus 2 and 6. Let's do this again. State the intervals of increase and decrease. Our solution method will always be the same. Find the critical numbers and draw a number line. Finding critical numbers, prime it, zero it, and solve it. F prime of x, top thing prime times the bottom thing minus the bottom thing prime times the top thing over the bottom thing squared. Simplifying. And now we're looking for critical numbers. To do this, we have to set the derivative equal to 0, which means the entire fraction is 0, so just the numerator needs to be 0. And if x squared minus 1 equals 0, x equals plus or minus 1. Drawing our number line, our f prime of x number line, labeled as such, putting on the critical numbers and any number where the derivative is not defined. So we would be suspicious of this denominator here and make sure that there's no x values where this is not defined. But we see that it's x squared plus 1. That can't ever be 0 because it's a square, which is a non-negative. Any square is non-negative. It could be 0, but it can't be negative. And then we'll add 1 to that. So this can never reach 0. So we don't have restrictions on our domain here. So we can just relax and say the critical numbers are negative 1 and 1, put them on the prime line, and now evaluate the intervals. The arrowhead on the end means you can sub in something large and negative. Something large and negative when squared becomes something huge and positive. Over a square, which is positive, and a positive over a positive is a positive. Between minus 1 and 1, we have the number 0. Subbing in 0 here to the derivative for x, we have negative 1 over a square, which is positive. So that entire section will be negative. And finally, on the end, there's an arrowhead on the end. So something large and positive when squared is something huge and positive over a square, which is also positive. So that section must also be entirely positive. Now that we've drawn our prime line, we can look at it, and wherever we see a plus sign, it's an interval of increase. F of x increases for x greater than 1 or x less than negative 1. And wherever we see a negative sign, we know that the function is decreasing. A third example, state the intervals of increase and decrease. Solution method, the same. Prime it, zero it, and solve it. Well, f of x could be rewritten by this, x plus 9x to the minus 1, just to make it perhaps a little easier to differentiate. Differentiating, negative 9x to the minus 2, we could put it on the bottom. And setting it equal to 0 means there's a 0 here, so we can drag the negative 9 over x squared across and make it positive, and it would look like this. Multiplying both sides by x squared, it looks like this. And so x equals plus or minus 3. Making our number line, our f prime number line, putting our critical numbers on it, but we have to be careful here. We'll put a negative 3 and we'll put a positive 3, but we have to look at the derivative and say, is there any number where we can't find the derivative? And x cannot be 0. Because this would be 9 over 0 squared, and that's a problem. So that 0 number has to go on our prime line as well. Make sure you put them in order. Negative 3 is the smallest, it goes on the left. 3 is the largest, it goes on the right. And now we've divided our number line up into 4 sections. We could start here, and let's work our way to the right. Starting here, any number in here will do. We can sub any number in here into the derivative to determine if the entire section is a plus sign or a minus sign. Well, 1 seems easy to sub in. Subbing in a 1, we have 9 over 1, which is 9, and 1 minus 9. Well, that entire section must be negative. We got the arrowhead on the end, so we can sub in something really large and positive. Now, 9 over something huge is very, very tiny. Very tiny, like less than 0.00001. So 1 minus something tiny is going to be positive. Working our way to the left, let's sub in -1. -1 squared is 1. 9 over 1 is 9. 1 minus 9 is negative. The entire section is negative. And this section on the end with the arrowhead, something huge or something large and negative. Plug it in here. When you square something large and negative, it becomes something huge and positive. So 9 over something huge, well, that's tiny. So 1 subtract something tiny is positive. And so wherever we see negative signs, we have intervals of decrease. Wherever we see positive signs, we have intervals of increase. Increases for x greater than 3 or x less than -3. Decreases between -3 and 0 and between 0 and 3. Sometimes you're given information about a derivative and you're asked to sketch a function. This information could be in a paragraph, it could be in bullet form, or you might be given a graph of a derivative like this. Solution will always be, when given information about a function, make that prime line, if possible. If possible, make a derivative number line, because it's a visual about the intervals of increase and decrease of your answer. So we'll construct a derivative number line. And we'll look at the derivative, and we can see that the derivative is 0. This is the derivative, and the derivative is 0, because the derivative is the y values of this blue line, and the derivative is 0 at -5 and -1. So we'll put those numbers on our derivative number line. Now looking at this derivative, we can see that all the y values on the blue line to the left of -5 are above this axis, and so they're all positive. All these y values are positive. So everything to the left of -5, f prime of x, they're all positive. And we can see that between -5 and -1, all these y values on this derivative are negative. They're below the x-axis, so we can say that interval is an interval of decrease. And everything to the right of this -1, we can see that the y values of that derivative are above the x-axis, and so they're all positive. This is a visual that tells us a lot about the curve that we're trying to sketch. It says you climb and climb and climb until x equals -5, and then you descend, descend, descend until x equals -1, and then you climb and climb and climb. So on our answer sheet, we need to draw a function that's climbing, climbing, climbing until x equals -5, and then descending, descending, descending until x equals -1, and then climbing and climbing and climbing. That's one solution. Climbing until x equals -5, descending until x equals -1. But answers may vary here because this isn't enough information to define a function completely. It just gives us the shape of it, because this function fits the bill as well. It climbs to -5, descends to -1, and then climbs again. As does this function, also fits the bill as well. It climbs until x equals -5, descends until x equals -1, and then climbs again. So answers may vary. And we also know that the derivative of a cubic is a quadratic. So that might also help us sometime.